Okay guys, today we're going to cover the properties of logs. So some of this will be a review from yesterday, and then we'll learn a few new things as well. So we're in Unit 9, Day 5. So the first thing we're going to do is we're just going to review the power rule from yesterday. So if we have, our equation is log base x. We have our exponent to the y here. This is just a reminder that if we have this exponent up here, we can bring this around to the front so that it's y log, put our base down here, and x. So that's just a review of what we did yesterday. So this is like multiplication. So you're bringing your exponent out into the front. So let's take a look at our shortcut method that we're going to talk about a little bit today. So we're going to talk a little bit about that, and then we have one more that we're going to review. So the shortcut method we're talking about looks like this. So if we have our logarithm and I have our base, in these two different spots, basically what we're telling you right here is with these two, they're going to cancel out and they're going to equal 1. So if you see something like this, it's just going to be equal to 1. So that shortcut method will allow you guys to just cancel those out and be left with whatever number you have left over. So we'll see the power again, we'll see the shortcut method, and then the last thing we're going to do today is the change of base. So the change of base is if I have the log base x. If I have my equation, it starts like this, and I see very clearly I'm not going to have nice numbers here. There's the change of base formula. We're going to use this to put into our calculator. So all we're going to do is take the log of our bigger number here. So log of x. Remember that you need parentheses around this when you put it into your calculator, so you would just put the log of whatever number is here. Make sure you close out your parentheses, and we're just going to divide that by the log of our base. Same thing with the parentheses, so make sure you close those out as well. So let's get started. We'll work through some of these problems together, and then if you guys have any questions, feel free to just pause the video and go back up to the notes that you guys have at the top here. So the first thing we have here is, if you look at number 1, I'm going to try to keep my notes in the screen a little bit for you guys so you can see those as well. So if you look at number 1, it's an example of the power, so of our power rule. So we're going to take that 4 and we're going to bring it around to the front. So we now have 4 times log base 6 of 6. So our shortcut method told us what? If we have the log base and the base number is the same, right, just like what we have down here, log base 6 of 6, those cancel out. So I can just cancel both of those out, and I'm left with just my 4. So not too difficult for you guys here. So let's try number 2. Same thing again. So we have our little exponent, our 6. We're going to bring that around to the front. So we now have 6 times log base 4 of 4. So those 4 and the log of base 4 is going to cancel out, and we are left with 6. Same thing on 3. We'll bring our 5 around, and we're going to cancel those out, and we're left with just 5. So if we look down at 4, 4 looks a little bit different than what we have here, but kind of follows along the same guidelines. So let's look at this. You can cancel our 5 and our log of 5 here, and what are we left with? Just our 10. Looking at 5, same thing again. We can cancel these two out here, and we're left with just 8x. And last but not least, let's look at number 6. Same thing again. So we're left with 32. So please make sure you guys remember that these are the same. So I have my 5, and then my base down here is a 5 as well, so when you're canceling those out. So let's look at the second page here. And again, keep your notes out. If you guys have questions, flip back and reference those if you need to. So number 7, we're doing the change of base form. So if you look back at your notes, the change of base form has us just dividing that and putting it into the calculator. So make sure you get your calculator. If you do not have it, pause right now, grab your calculator, then start the video up again. So what we're doing is, here I have my calculator right here. All we're doing is doing the log. We're going to put 27 in our parentheses here, and we're going to divide that. So go ahead and plug that into the calculator. So we have log of 27. And notice, remember the parentheses, please, and then your answer comes out to 1.5. So same thing for 8, 9, and 10. So go ahead and set up your problems and plug those into the calculator. So we'll start with a bigger number here, so log of 16. And we're going to divide that by log of 8. So plug that into your calculator. Don't forget your parentheses. And you get kind of a repeating decimal, so just to the hundredths place. So just 1.33 is fine for that one. Same thing on 9. We'll do the log of 13 divided by the log of 5. And let's put that one into the calculator. And we end up with 1.59. And last one is 10. So we'll write that out first. Log 21 divided by log of 8. And we'll put this one into the calculator as well. And we end up with 1.46. So when we look at 11 and we look at 12, it's not quite as simple as you think. You can't just plug it into your calculator as it's written. So what we're going to do is use the change of base rule that we have, and we'll plug it into the calculator like that. So if we're doing exactly what we did up top here, we're going to do the log of x divided by the log of 2. And so we're going to go to our y equals, and we're going to plug that in exactly. So we have our graph down here. So we'll do log of x divided by the log of 2. And go ahead and hit your graph. So notice here our graph starts kind of low right down here, but if you look really closely, we have an asymptote on this. What that means is we have that imaginary line right here where the graph never passes through. So we'll kind of draw that in our graph as well. So from here, I'm just going to go to my table and find like 3 or 4 nice points. So I'm going to start with So here I am. I'm going to just start with my table right here. So I'm going to do x and y. So I will start with 1, 0. My next nice number is 2, 1. And then 4, 2. And let's scroll down. I'll do 8, 3. So I'm just going to plot those points and finish up my graph. So we'll do. I'm just going to connect these right here. So I'm going to do a couple points down as well. And I'm just going to kind of curve this. But remember, I said I have that asymptote, so I'm not going to cross that line right there. So just a nice curve to my graph right there. So same thing with 12, exactly what we did before. However, this time we have our 3 in front, so we're just going to keep that separate. So we're going to do 3 times, and now we're going to do the change of base rule. So we're going to do 3 times log of x divided by the log of 5. So we'll plug that into our calculator this time. So we'll do 3. We're going to do times the log divided by log of 5. And same thing again here. So we see kind of our imaginary asymptote that we're avoiding that line right down the middle of our graph. So let's go to our table and let's look for some nice points. So I'm going to scroll up. I'm going to start with the point 1, 0 again. And then I'm going to go down to 5, 3. See if I have any other nice points. Nothing all that nice, so I'm going to just make a guesstimate right around like 9 and 4.09. Just so I have 3 points on my graph here. So I'll graph these 3 points. So I have my 1, 0, over 2, 3, 4, 5, up 3. And I'm going to go, so this was 5, 6, 7, 8, 9, and just past my 4 right there. So I'll connect these 3. And then again, I'm going to bring my graph kind of right down, but I'm not going to cross that line there for my asymptote. And that's how we're going to graph using the change of base formula.